Alright, so let's take a look at angles in standard position, and this is going to be a really useful model, especially when we look at future trigonometric equations, identities, as well as just in general the special angles when we look at the unit circle, right? So it is very advantageous to kind of understand angle in standard position. Now, before we can actually identify what that is, we need to understand that an angle is a degree of rotation. Angles are degrees of rotations between reference lines or rays. Okay, and a line we can understand is just is basically just like a straight edge, right? We're specifically looking at line segments, but a ray here is basically just like an arrow. Okay, and we're going to basically be looking at rays, and the two rays that we're going to be looking at is one of the rays is positioned on the x-axis. We're going to call this ray, we're going to call this ray the initial arm. So this is the initial arm. It's always positioned on the x-axis, right? So the initial arm is positioned at the positive x-axis. And another ray that we're going to be looking at is something called the terminal arm. And the terminal arm can be located on the initial arm or away from the initial arm. So let's say the terminal arm is located here. Okay, so this guy here is called the terminal arm. Okay, and the terminal arm is some rotation from the initial arm. Okay, and the degree of that rotation can be assessed by an angle theta. So this is theta. It's a degree of rotation between the terminal arm relative to the initial arm. So we're looking at rotations from the terminal arm relative to the initial arm, and we can understand that rotations can be positive or negative, right? So in standard form, positive rotations are counterclockwise, okay, and vice versa. So in standard position or standard form of an angle, positive rotations are counterclockwise, so that means that theta, if it's greater than 0 degrees, it's a counterclockwise rotation from the initial arm to the terminal arm, okay? And if theta is less than 0, this is a clockwise rotation from the initial arm to the terminal arm, right? So it's all the rotations are relative to the initial arm, right? And here we've shown that theta should be positive because of the fact that this is a counterclockwise rotation. You can see that it's basically going this way, right? The terminal arm was positioned here, for instance. Let's say it was located here, right? A negative rotation would be like that. So this would be negative theta, okay? That would be a clockwise rotation. Now, anyways, so we know that angles in standard form, there's an initial arm that's located on the positive x-axis. It's our reference point, and we are associating this with a terminal arm. The other thing to note about standard form is that the vertex of the two rays or the lines, vertex of the rays or lines, that should be the origin. Okay, so the origin being, so this is a vertex. A vertex is a combination. It's basically where two lines or rays meet. The vertex here is the origin, which is 0 and 0. Okay, and because the vertex is the origin, we can look at the position of the terminal arm from the vertex as a coordinate x and y. Okay, so we can look at the position of this terminal arm from the vertex, and this point can be expressed as x and y. Okay, so let's try to shorten this out. You can see that there's a grid system here. It's gonna shorten this terminal arm out. Say we place it here. Okay, using the grid system, this is a point. right? This is the point 2 and 3. Okay, so that means that the y-coordinate is 3, this coordinate is 2, and you can actually find the angle associated with that by using the trig ratio. We can understand that x and y are 90 degrees apart, right? So in this case, if the point is 2 and 3, right, we can use the tan ratio, and then tan theta here is equal to 3 over 2, and then theta is equal to the tan inverse of 3 over 2, okay? So you can actually figure out your trig ratios, right, because of the fact that x and y dimensions are 90 degrees apart. Furthermore, if you want to find the other ratios, you use Pythagorean theorem, and you do a squared plus b squared is 4 plus 9, which is square root of 13, right? Because if you do square root of 2 squared plus 3 squared, you get square root of 13, okay? And you can also figure out your sine ratio. So sine, in this case, if this is theta, right, because it's a counterclockwise rotation, which is positive, right? I'm just gonna make this a lot nicer to look at. If this is theta, then we can understand that sine theta is 3 over square root 13, and cosine theta is 2 over square root 13. So that's another benefit of having the vertex at the origin, because we can represent the terminal arm as a coordinate, as a point of x and y, and then we can create a right angle triangle, right? So these are just some tenets that you kind of want to remember here, right? That counterclockwise, the initial arm is basically a reference ray, and it's positioned at the positive x-axis. The terminal arm is a rotation away from the initial arm. Rotations can be, sorry guys, the rotations can be positive if they're counterclockwise, negative if they're clockwise, and the vertex is positioned at the origin, and the terminal arm's position can be represented in terms of x and y. Okay, so this is an angle in standard form, so make sure you guys can kind of understand that. All right, so the next thing we're going to be looking at is what we call a unit circle. It's going to take in this idea to account, right? And you can also understand that if you do a full rotation of this terminal arm, right, whoops, you do a full rotation of this terminal arm from the initial arm, and you go back to its original position, you actually create a circle, okay? And then the terminal arm, the length of the terminal arm here becomes the radius of the circle. Okay, so that's another idea that you can kind of understand. All right, so we'll move forward.